Hey everyone, and welcome back to CS196. And welcome to part 2 of Bash. So let's quickly go over our objectives for today. So firstly, I want to teach a few more commands in Bash, the ones listed down here, and I want to go over logical operators too. I then want to go over text editors in Bash, the ones listed here. I want to go through aliasing. And finally, as an extra bonus, I want to go through an intro to Bash scripting. So let's get right into it. Our first command for today is a super useful one. It's called sudo, and sudo stands for super user do. What sudo does is it gives the user root privileges. So that's similar to admin rights. So the usage is if you type sudo and then some command, you'll be prompted to type the root password, which will be the password of the admin or whoever the super user is, and the command will be run as a super user. So for those of you who are unsure who the root user is, think of the root as the administrator for your computer or your network or whatever you're working on. They essentially have the power to do whatever they want on the machine. So with that being said, with great power comes great responsibility. With sudo, you can do anything, potentially even mess with your computer, delete important files, delete things that might prevent your computer from running as well as it should. So be incredibly careful when using sudo and only use it when you know exactly what you're using it for. So for example, let's say I wanted to create a file using the touch command as super user. So what I would do is I would write sudo and then the command. So touch, let's call the file sudo. After I run the command, I'll be prompted with a password like so. And notice as I type my password that nothing is actually showing up in that password bar. So let me put my password in. And now this command is run as a super user. Now this isn't a really exciting option because you know that you can create a file even if you're not the super user, but for more powerful things that require a super user, you can use sudo to get that extra access, like for accessing restricted files or something like that. Notice now though, if I want to delete the file as super user, file sudo, I won't be prompted for the password again because they know we're in the same session and we're probably still the same user. So remember, be very, very careful when using sudo because you can do anything with it and you really don't want to risk messing with your computer. And here's a fun tweet that I found. It's what I imagine parenting's like. So, parent, can you please clean your room? Kid, no. Parent, sudo clean your room. Yep, fine. I know it's not that funny, but I thought it was pretty funny, so. Next we have echo. So the echo command essentially allows you to print into bash. So this seems kind of useless initially, but it's very useful when you're chaining longer commands to debug what went wrong. So your usage for the echo command is, is you write echo some string, and then the some string that you put after echo will be printed into the terminal window, and it will be ended with a new line. So what's important about that is that it just means that your next prompt will be on a new line, not the same line as the string you printed. And I'll show you that in our example. So if we wrote echo hello bash world, this will just print this message into the terminal window. So let's try and recreate that in our terminal window here. So let's echo, open speech mark, hello bash world, closing speech mark, enter. And just prints that there. And what I meant by saying it puts a new line character at the end is what happens here. Notice how this intro to bash thing doesn't just start on this new line, on the same line here. There's a new line character here that pushes us down to this line down here for the prompt. So this might not seem very useful, but it's useful when you're chaining longer commands so you can debug what went wrong with longer bash commands or when you're writing bash scripts. Think of it as a regular old print statement. Let me hide my camera there. So now we're on to find. Find is a really powerful tool for locating files. And once you find a file, you can then run commands on those files that you just found. So the usage is you put find and then your path to the directory, and then hit enter, and the path to all the files in that directory will be printed to terminal. And this includes files inside directories inside the directory specified. So let's try find dot and see what happens. So notice here, we're in the intro to bash folder. But within the intro to bash folder, is a bunch of other directories, other folders in them, and with other files in them. So let's do find dot. So the dot indicates the current directory. And notice all the files that are in here are now being printed, and all the files that are within those directories are also being printed, like so. So this is a really useful way to find out exactly what's in your directory. So let's say I wanted to find out what was in just directory 2. I could do find directory 1, directory 2, give that path, and now we see what's in here. So this alone might not seem super useful, but we can build on this like so. So if you use the flag name followed by a file, you can find the paths to specific files. So let's say you have a really big project and you want to find a specific file. This is a really useful way to do that. So usage is if you type find the path and then use the name flag followed by the file name. When you hit enter, the terminal will print the path to the files with that name. So let's first demonstrate that before we go into wildcards. So let's say we're looking for this file in dir.txt. What I can do is or let's say I know this file is here, somewhere within intro to bash. What I can do is I can do find dot, because that's the path, we know it's somewhere within this directory, and then do name file in dir.txt. So trying to find this file here, or the path that file there. We enter, we get the full path all the way to where we want to be, relative to where we were initially, which was the intro to bash folder. So this is really good when you're trying to find a specific file or a path to a specific file from a higher level folder or from a very large a folder with a bunch of files in it. But what makes it really useful is if you use wildcards. So the asterisk wildcard can let you select a group of files. So for example, if I do asterisk.txt, what that's saying is we don't care what comes in the asterisk as long as the file ends in .txt. So this will select all the text files. And so also, let's say we have something that says 196 star.txt. This will find all text files that start with the string 196. So essentially all files that start with the string 196 have something in the middle, we don't care what's in the wildcard, and ends in .txt. So firstly, let's try and find all the text files that are within intro to bash. So we first do find dot to indicate the current directory. And now, at least on OS X, you have to put speech marks when using wildcards or trying to find a name. So you do name, speech marks, asterisk to indicate that we don't care what the file is called, just as long as it ends in .txt. So you use pattern matching. When we enter, we see all the text files that are within the directory, not just within this level here, but in all the lower levels too, have been listed out here. And that's really useful when you're trying to find a specific file or a specific type of file within a huge directory. So now, let's create a bunch of files that start with 196. So touch 196 a.txt, touch 196 ab.txt. Oh, I spelled it wrong. Okay, so a bunch of files now here that all start with 196. And if we want to find only the files that start with 196, we use find dot to indicate the current directory, name, and we put 196 wildcard.txt. And what this is telling bash is that, or the find command, sorry, is that we want whatever we're looking for to start with 196. We don't care what's in the middle because there's a wildcard here, and we want it to end in .txt. So now, when I hit enter, we see that all the files, oh, sorry about that, let me make this a little smaller. And now we see that all the files that we just created that started with 196 and ended .txt are being listed here. And I'm sure I don't tell you why this is really useful in trying to find files within larger directories, because you're using pattern matching to specifically get what you're looking for. And another point on that is if you use the iname flag, it'll make your search case insensitive. So using the name flag is case sensitive, iname will make it case insensitive. Just demo that quickly. Let me make two files. Let's call one cs.txt, and let's call one cs2.txt. If I just try find cs star, so to say starts with cs, doesn't matter what it ends in, we only get this file here. But if I do iname and I hit enter, both those files are listed because we're saying that we don't care if this is sensitive, case sensitive, or case insensitive. And just to go over this pattern matching again, we're just saying we want files to start with the CS, or in this case C and capital S, and whatever comes after that doesn't matter. We have a wildcard. Now we have the delete flag. So if you use the flag delete, all the files that are returned by the find command will be deleted. So for example, if you type find path to directory and then use the delete flag, when you hit enter, all the files in that specified directory will be deleted. So all the files that are returned by find will be deleted. Secondly, if you type find path to directory and then use the name flag and specify a specific name of a file or a specific pattern match, and then hit delete, when you hit enter, all the files of that name and specified directory will be deleted. So this is a great way for us to get rid of all of these files we created with the 196 start. So just as a recap, let's try and find them first. So 196 star.txt. And now we see all those files being listed here. If we add delete, now when I try find, nothing's coming up because we deleted all those files. Next, we have grep. Grep is a really powerful tool. It stands for Global Regular Expression Print. So grep is used to search for text and return matching lines in a given file. So its usage is if you type grep, the text you're searching for, and then a file to search for, and hit enter, the terminal will print the lines where the search text was found in file to search. So for example, we have this file here called names.txt, which I'll show you in a minute. If we grep Rohan, it'll print all the lines in names.txt where Rohan was found. So let's first cat this file, names.txt, and this is what it says here. If I do grep Rohan names.txt and hit enter, all the lines where Rohan appears will be printed out here. Notice that it's case sensitive. Rohan here and Rohan and Sammy down here, which starts with a lowercase r, have not shown up. So now we have the W flag with grep. Using the W flag will return only exact matches, not just a partial match. So example, if a file has the words Rohan and Sammy on two separate lines, grep will return both the lines. But if we use W flag, then only Rohan, the first example, will be returned. So the way we use this is, the usage is grep, search text, file to search, similarly as we did before, and then it's W flag. So firstly, notice here when we did grep normally, this appears here, this appears, but then not Rohan also appears because this is a part of that word. Similarly, this also appears. If I use the W flag, these two options get removed because this isn't an exact match of the search text that we're looking for. Notice also that Rohan and Sammy, this full sentence is returned, and that's because there's an exact match of the word we're looking for within this entire sentence. Next, we have the I flag. So using the I flag will make the search case insensitive. So for example, if a file has the words Rohan and lowercase Rohan on two separate lines, grep will return only the first line because it's case sensitive. But if you use the I flag, it will return both the lines. So the way we do this is we just put an I flag at the end of our grep, or at the start if you want to. You can also put the flag over here. Hit enter. And notice all instances where Rohan is put, not just where it's a capital R, have been returned. Another cool thing with grep is that you can stack flags on top of each other. So for example, if you do grep wi and then you put whatever you're searching for, it'll look for a case-insensitive search and also an exact search. So what does that look like? Well, first let's look at what a regular grep for Rohan and names.txt looks like, right? And let's just cat names.txt as well, so you know what's in here. If we want only a case-insensitive, but with an exact match, we'll only get these 3 lines, because these are the only lines which are case-insensitive and match Rohan, and also where there's an exact match. No concatenated words like this, or like this, or like this. grep is very useful in searching large text files and large documents to find exactly what you're looking for. Now we have diff. Diff is short for difference, and diff will compare 2 files line by line and identify the lines where they differ. So for example, if you type diff file1 and file2 and then press enter, you will see the differences between file1 and file2 printed in the terminal. So for example, I do diff a.txt and b.txt as the 2 arguments. It'll print the differences between the 2 files in the terminal window. If files are identical, then nothing will be printed. So let's try and demo this. Let's create a file. Let's call it a.txt. Another file called b.txt. If I cat these files, and I cat this one, notice that there's nothing in them. They're pretty much identical. Not pretty much, they are exactly identical. There's nothing in them. If I try and diff them, nothing is printed because they have no differences. But let's say I put something a.txt. So we're using a Vim text editor, which we'll cover shortly. This is A. If I diff this now, notice it tells me where the difference occurred, and it'll tell me what the difference was. If I put something into B, and diff it, we see that the differences are both being listed here. So this is useful when you're trying to, for example, look at 2 outputs and see whether they're the same, whether they're different, trying to analyze them, because this is a great job of finding exactly where the differences are and printing them into terminal window for you to use. Okay, now we're moving on to logical operators. So this is ampersand or the AND logical operator. So what it does, it lets you do several commands sequentially, all in one line, as long as all the preceding commands complete successfully. So what does that mean? So let's look at the usage first. If you type command 1 and command 2 and command 3 and command 4 and hit enter, then all the 4 commands enter will be done one after the other. So we this one first, then this one, then this one, then this one. But let's say this one runs, but then command 3 fails, command 4 will not be run. All the preceding commands have to be completed successfully for the command to be run. So for example, over here, if I do make directory 3 and cd into directory 3, touch new file, and then cd ... what this does is it'll create a new directory, move into it, create a new file within that directory, and then cd out of there. So let's actually just demo that. So we're entered a bash right now, we're over here. If I do mkdir dir3 and cd dir3, not die, dir3, and touch testing.txt and cd ... Notice it looks like nothing happened. You did see a little motion here, I'm sure, but if I print the working directory, I'm in the same spot as I was before. But if I list, notice that this is a new directory 3, and if I list the contents of directory 3, testing.txt exists there. But now watch. Let's say I try to cd into some random file. This folder doesn't exist, and then I try to echo this message. So we know that this directory doesn't exist, as you can see here. We can also use find if we wanted to double check that. When I hit enter, notice that this message wasn't printed. Well, that's because, as shown in this error message, this didn't complete successfully. This first command didn't complete successfully, so we didn't go on to the next one over here. And now we have the OR logical operator. So it looks like these two vertical bars. So first, the way this works is, it'll try the first command, the one preceding the OR logical operator, and if the first command fails, it'll do the command after the logical operator. So in the usage here, you see if you type command 1 or command 2 and then press enter, Bash will first try to run command 1. If command 1 completes successfully, then this whole thing ends after command 1 runs, but if for any reason command 1 fails, it'll run command 2 instead. So this is a good way to double check if something that you ran worked successfully. You could say like, run a Python script here, and if there's any error, like just run this instead. So for example, if you try to cd to this not a real directory, this is a fake directory, or echo that doesn't exist, if this first directory doesn't exist, it will lead to the second command running, and it'll let us know that that this one failed. So let's actually try that here. So let's cd fake dir, and we know, looking over here, that it doesn't exist, or echo that directory doesn't exist. Oh, just missed I put the close mark there, that's weird. Anyways, so what happened here was it said, nope, this directory didn't exist, and then it echoed this message here. Another cool thing you can do is you can chain logical operators. So you can chain long operations into one line using different logical operators. And that's really useful if you want to try to do multiple things at once with like these checks, like with the OR statements, for example. So what would this command do? Take a look at this line here. And you can pause the video here and try and guess what this would do. I'm going to copy this so we can run this in our terminal window. Okay, now that you guys had a second look at it, let's run this and then walk through what happened. Okay, so firstly, it tried to cd into this fake directory. Well, we know there's no fake directory, so it told us that, because it told us that here. There's an error. There's an AND operator, and it was going to echo and move the fake directory. But because the preceding statement failed, this was not run. And because this whole statement failed, this was run instead, and it said there was no directory there. Pretty straightforward. This is useful for running long commands and having a little check to see if anything preceding it failed. So now we're going to move away from commands and try to move to text editors in Bash. So firstly, how do we edit a regular file? Well, if we want to edit a normal file, we just use a text editor like VS Code or Notepad. But how do we edit files within Bash? Well, again, we use the text editor. So these will be different from ones you may be familiar with because you can't actually click on anything within Bash text editors. So despite this initial learning curve, they can actually be very powerful and efficient, and sometimes you are forced to use them. For example, let's say you're working on a VM right out of your terminal, like you SSH into a VM, or for server-side scripting, you try to SSH to a server, you might be forced to use a text editor within Bash. So the most popular text editors in Bash are Vim and Emacs. We'll also go over Nano, which is not as popular as these two, but it's definitely the easiest one to start learning, and the one I started learning with first. So let's start off with Vim. Vim is a popular terminal editor that was released in 1991. So you start by typing Vim followed by a file name. If the file exists, then Vim will open the file, but if it doesn't exist, then if you save after closing Vim, it'll create that file. So let's follow along with this. Let's do vimfile.txt. So when you open up Vim initially, it opens up in command mode. And this can be identified by lack of description at the bottom of the window. Like so, just as the file name. So in command mode, you can use these keys to quickly navigate and do a few powerful things. So firstly, before we do this, let me put some data into our text file. This is Vim file, text file with some random words and other bits of info. Okay, I'm happy with that. Now let's look at some of the command mode shortcuts. So firstly, we can use HJKL to go left, down, up, right. So J and K are used to move down and up respectively. L is used to move right, and H is used to move left. You might think that's a pretty weird set of keys to use, but if you look down and keep your hand there, you notice it's actually right in the hotbar. And by doing this, you can navigate quickly through your text file without having to move your hand around to the arrow keys or your mouse. Next, we have the $sign and then the underscore. A $sign will move your cursor to the end of the line, and underscore will move your cursor to the beginning of the line. So if you do $, you'll go over there, underscore will take you there. W and B are pretty cool. They move your cursor forward and backward one word at a time. And we can use this /some word to move the cursor to the next occurrence of that word. So first, let's do WB. W takes us forward, like any video game you play on your keyboard, and B takes you backward one word. And if you reach the end of the file, it'll stop you there. And if you do / and you write some word, for example, let's write bits, it'll take you to the next occurrence of that word. Like so. Notice how it appeared down here. You can also move around the file. If you use line number followed by GG, it'll move the cursor to the start of the line with the line number you specified. So if I did 1 GG, it'll take me to the first file. If I did 4 GG, take me to that fourth line there. Again, a quick way to navigate through your file. Now you have DD. DD deletes the line that the cursor is on, and U is undo. So let's demonstrate that together. Let's go up here, do DD. We deleted that line entirely, and U brings it back. So command mode is a really great way to quickly navigate through your file and have quick interaction with the file itself. But how do we actually put stuff into our file? Well, if you press I, you can enter insert mode. In insert mode, you can use the keys normally. So you insert data that you want to the file, and if you press the escape key, you'll go back to command mode. So if I press I can now entering data into file, and I can use the arrow keys to move around the file. Notice if I try to use the hotkeys like HJKL, it won't navigate the file, it'll just type into there. And if I type escape, I go back into command mode, and I can do all the things that we went through in the last page. Finally, very importantly, how do we exit Vim? And this is actually kind of a CS meme because people get stuck in Vim and there's no clear way of leaving it. To exit Vim, you need to firstly return back to command mode and either press :Q to quit. And this only works if you haven't made any changes to the file, like if you just use Vim to read the file. :Q ! To quit without saving, and :WQ to write and quit. So let's firstly try and just :Q out of this. Well, let's say no, because you've made changes here. But if I do :WQ, I'll be saving and quitting. And now we have a new Vim file here. And just to make it clear, a Vim file isn't different from regular files. This is just a regular old text file. I just called it Vim file so we know what we're working with. So I do Vim file here, and I delete everything. If I exit and I use Q!, when I cat this file, notice that none of those changes were saved. Emacs is another popular terminal editor that was released in 1985. So to start Emacs, you type Emacs followed by the file name, very similar to Vim. Also similar to Vim, if the file exists, then Emacs will open the file, but if the file doesn't exist, then if you save after closing Emacs, it will create that file. Emacs is similar to Vim, however, it does not use modes like Vim. Instead, commands are prefixed by the control keys or the meta alt option key. So alt for Windows and option for Mac. When you open Emacs, there are no modes, so you can start typing straight away. So let's demonstrate that. emacs.txt. So notice that straight away we can start typing. This is an Emacs created file, blah blah, CS196. It's cool. And I'm also just gonna scroll down here to show you how windows work, and then move up. So if you hold Control and then type A or E, you'll go to the beginning or end of the file respectively. If you type Control V, you'll move down one page. So a page is the amount of text visible on the window. So notice here we can only see this much, even though we know there's text below. Control underscore undo changes, and Control H will bring up a help page. So if we do Control A, it'll take us start of the sentence, and E will take us to the end. Like that. Control V will take us down one window. Let's say we accidentally delete this line here. Control underscore will bring back that line. It's just undos. Finally, something cool, if you do Control H, you get this cool tutorial on how to use Emacs. Next, if you hold the meta key or the Option or Alt key, depending on what device you're using, and then use F or B, you'll move forward or backwards respectively one word, and use A or E, you'll move to the start end of a sentence respectively. So for this, I'm actually going to move to terminal, because in iTerm, if you press the Options key, on a Mac at least, it has a few peculiarities, but on regular terminal, that doesn't exist. So Emacs random dot, I can't spell, random.txt. This is a random text file, blah, blah. So if I do Control B, Meta B, I move back one word at a time. So that's Option B on a Mac and Alt B on a Windows. Now if I do Option F, I can move forward like so. Again, A or E will take me back to the start and end of a sentence. Let me put a full stop here to demonstrate that. Take me back to here. Should take me back there. Oh. Let me put a full stop here, too. Okay, like that. So if you press Escape followed by a greater than sign, greater than sign, you'll move to the end of the file, and if you do Escape followed by less than sign, you'll move to the start of the file. So let's do Escape, greater than, go to the end of the file, Escape, less than, Escape, less than, take you to the start of the file, like so. To save a file in Emacs, you hold Control, then press X, then S, and to exit, you hold Control, then press X, then C. So let's demonstrate that. If I do Control, X, then S, that saves it, so you can see that there, because this file is not on my desktop. If I do Control, X, then C, we leave Emacs. You can close that. And again, if I list, you can see now that there's the Emacs file. If I cat it, all the information that we put in there is now there. Also fun little bit of information about Emacs, you can play a bunch of games inside it. I'm not going to mention that in the lecture, but you can look it up. You can play Tetris, this is Gomoku, bunch of fun stuff. Finally, we have Nano. So Nano is not as popular as Vim or Emacs, but it's very, very easy to use. So Nano was released in 2000 and has the smallest learning curve out of all the editors we've looked at today. So to start, you just type nano followed by the file name, and again, if it exists, Nano will open the file, and if it doesn't exist, then it'll create it if you save after closing Nano. So now you can go ahead and start typing as soon as you open up Nano, and the commands that you need are at the bottom of the editor. So I can just do nano file.txt, and I can just start typing. This is a nano file, random text, and everything I need is down here at the bottom. So to exit, I can just do Control X, Y to say yes, and I hit enter, and I can leave. And see if I cat that file we made, it has everything we just wrote in there. It's definitely the easiest one to use, and it's the first one I picked up. I personally use Vim, but you should try all three and see which one you're comfortable with. Now we're going to talk about aliasing. So aliasing is a powerful tool to create bash shortcuts. So we do this by using the alias keyword. So for example, the usage is you do alias followed by the shortcut name equals and then some command. So this will create an alias, so if we type shortcut name, this full command here, which is usually longer, will be run. And to remove the alias, we simply use the unalias keyword, like that. So let's say, for example, every time we do ls, we don't want it to just ls the files. We want it to ls all the files so we can see the hidden ones as well. That's pretty easy. We can just do alias ls equals ls a. So using the all flag. So now when I write ls, notice that all the files are being listed, not just the regular ones, but even the hidden ones too. But let's say we got bored of this and we want to go back, we can just do unalias ls. Pretty cool. Another cool thing you can do is, let's say when you open up bash, we know that we don't start off right in the desktop, we start off in a higher up folder. So let's say we want to go there directly every time we open up our terminal. So let's alias. So let's first see what the command is. cd desktop insert bash. Let's say we want to get here every time we open up bash. We can copy that. And we do alias. Let's say CS196 as our alias. Put this command in there. Hit enter. Now I type CS196. It'll take me right to intro to bash. Pretty cool. I can unalias it. Write CS196. And now when I write CS196, it'll tell me this command doesn't exist because we removed that alias. So now we've covered all the content that I think is relevant and useful for most of the work you'll be doing with bash and in your project especially. But as an extra bit of information, we're going to cover an introduction to bash scripting. So within bash, you also write scripts to run commands, and these can even take an input. So bash scripts have the .sh extension, and you can run the scripts by typing bash followed by the script name .sh. So let's first talk about variables within bash scripts. So you can declare a variable by choosing a variable name and then assigning a value to it. You do not need to declare the type of a variable as you have to do in Java, for example. It's like Python where you don't need to declare a type. To use the variable later, you put a $sign in front of it to indicate that it is a variable. And note, don't put spaces around your variables. So I have a bunch of scripts over here that we can use. So let's open these up in VS Code because that's easy to read. Let's first look at this bit of code here. So we have this secret variable, and it has some password there. And we're going to echo it. And to echo it, so echo, as we know, is a bash command. We use echo followed by the variable name. We use the $sign to indicate that it's a variable. So we have that over here. It's called var.sh. Let's run this. So as expected, it first prints the password on this line. Next, it prints the secret message says, whatever the password is, and then says it again. So these are two ways of identifying a variable within the echo. Now let's talk about conditionals in bash scripting. So you can also use conditionals in bash scripting just like you could in a regular programming language. For those of you who don't know what a conditional is, essentially it's if-else or if, elif, else statements. Elif is just short for else if. Essentially what this lets you do is make decisions on what should be run in the code based on the condition of certain variables. So note, let me get the red pointer for this, you need spaces between the condition and the bracket here. So your if-else statements are in this form, and they end in if backwards there. So you can use -eq as an equals operator for numerical comparison. So you could say like 5 dash, eq 5, and that will return true, or 5 eq 6 would return false. You can use -ne as a not equals operator for numerical comparisons. You can use equals as an equals operator for string comparisons, and you can use exclamation mark equals or not equals as a not equals operator for string comparisons. So take a look at this code snippet here. You can pause and take a look at it. We're also going to look at it over here. It's a little bigger. So firstly, we're declaring this variable num, saying it's 20. Stir is hello. First, we'll echo this, so we'll just say hello. We go to the first loop here. If num does not equal 20, then we print what it is. Otherwise, if string equals hello, then we echo hi there. Else, we print while I'm confused. So what do you think this should do? There was an answer down there, but what do you think this should do? Well, it should say hello and then hi there because string does equal hello. Let's write it like this, I believe. Yeah, don't need the speech marks around it. And it'll say hi there because hello does match hello, and I'll respond with that. So now, I'm going to cover that up. Take a look at this code snippet here. Let me comment this out. Oh. What do you think this code snippet should do? Pause there, read through it. Okay, I'm going to run it now. It said hello while I'm confused. Why did it say that? Well, the first condition is false because 20 obviously does equal 20. Secondly, this condition here is false because hello does not equal word. So we go to the else statement, which is while I'm confused, like so. Now let's talk about loops. Loops are a really powerful tool to let you do the same lines of code repeatedly. Lets you do a lot of things with a few lines of code. So the form of a loop is like this. So you do for some counter in some range here. This is the range. So it's your starting number to your ending number. And then you do whatever is here. Do something. Take a look at that. Now let's look at an actual example. So for I in range 1 to 10, do echo, we are on a loop, I. So what do we do here? Well, we're taking this variable here and we're echoing it in this string. So take a guess what it does. I'm sure it's pretty obvious. It just prints that we are on loop blank from 1 to 10. Now we have functions. So for those who don't know what a function is, essentially it allows you to take a chunk of code and give it and be able to call that chunk of code with a unique name. So function declaration is in this form. We give a function name, 2 brackets, and then we put all the stuff that the function is meant to do within those 2 brackets here. If you pass a value into the function will save this into $1. I'll talk about that in just a second. And the way you call a function is you put the function name and then the values that you're passing into it. So let's look at this function here. So we have this greet person function here. So what it's doing is it's echoing, so printing, hi there, some variable, you look, second variable. So let me talk about these variables. You're probably wondering, why are we starting at 1 and not 0? I thought this was a programming language. Well, the first variable is actually greet person. This is $0. That would be the function call itself. The next variable would be $1, $2, $3, etc., etc. And you can use those variables within your function here. So if I comment this line out and I try and run this, nothing happens. That's because a function doesn't run on its own. You have to call the function, like on this line here, line 5, for it to do anything. So now, if I call the function, it'll say, "Hi there, Rohan, you look great." But let's say, I got out of bed late this morning. We can change the variable to pass this function and say, "Hi there, Rohan, you look okay." And again, if you wanted to add a third variable, we could just simply add it like so. Let's put it is cold today. Like that. And with that, we're at the end of the lecture. I hope you found the content we taught today interesting, and I hope you learned something. Bash scripting is tricky, so if you found that confusing, don't worry about it. This is not something we're going to be testing you on, but it's a cool extra credit opportunity, and we will be offering you guys extra credit if you can do some bash scripting later on this week. So if you have any questions, make sure you drop them in Discord or on Twitch, and I'll see you in the next one.